Section 1. The balloon rocket. A simple start. Have you ever blown up a balloon and let it go? The air rushes out the back, and the balloon flies across the room. That's a mini rocket. It works because of a simple rule. Every action has an equal and opposite reaction. Inside the balloon, the air pushes out in every direction. When you let go of the balloon's neck, the air has an escape. It rushes out the open end. This is the action. The reaction is the balloon moving forward. The air pushing out the back forces the balloon to move in the opposite direction. This same principle, called thrust, is what powers massive rockets into space. Of course, real rockets are much more complicated than balloons, but the basic idea is the same. A balloon might seem tiny compared to a giant rocket, but they share key features. Both use the power of thrust to move. They expel something like air or hot gas in one direction to generate movement in the opposite direction. However, there are important differences too. Rockets use powerful engines to burn fuel, creating hot gas that's expelled at high speed for thrust. Balloons rely on the simple release of compressed air. Another difference is fuel. A balloon uses all its fuel, the air inside, at once. Rockets carry a large amount of fuel and burn it gradually, allowing them to sustain thrust for much longer and travel much farther. Sir Isaac Newton, a brilliant scientist, developed 3 laws of motion that explain how objects move. These laws are essential for understanding how rockets work. The first law, the law of inertia, states that an object at rest stays at rest, and an object in motion stays in motion at the same speed and in the same direction, unless acted upon by an unbalanced force. The second law explains how force, mass, and acceleration are related. It states that the acceleration of an object is directly proportional to the force applied and inversely proportional to its mass. Finally, the third law, the law of action and reaction, is what we see in action with our balloon rocket. For every action, there is an equal and opposite reaction. Section 4. First law in action, inertia, and the motionless motion. Imagine a soccer ball sitting on the grass. It will stay there forever unless something kicks it, right? That's inertia. The ball wants to stay still. Now imagine kicking that ball with all your might. It flies through the air because your foot applied an unbalanced force, overcoming the ball's inertia. In space, there's very little friction. So a rocket moving at a constant speed will continue moving at that speed and in that direction forever unless acted upon by an external force, like gravity or a course correction. Section 5. Unbalanced forces, the push for space. Remember our balloon? The air rushing out was an unbalanced force. It overcame the balloon's inertia and set it in motion. Rockets work the same way, but on a much larger scale. The force of the hot gas being expelled from the engine is far greater than the force of gravity pulling the rocket down. This unbalanced force propels the rocket upward. As the rocket burns more fuel, it becomes lighter. This means that with the same amount of thrust, the rocket accelerates faster and faster as it climbs higher and higher. Section 6. Earthly examples. Cosmic connections. Think about walking on a moving walkway at an airport. Walking in the same direction as the walkway makes you go much faster. Walking in the opposite direction slows you down. These are examples of forces working together or against each other. Now imagine you're on a plane. Even though you're moving very fast, it doesn't feel like it because you're moving at the same speed and in the same direction as the plane. This is like a rocket in space, coasting at a constant velocity. These everyday examples demonstrate the same principles that govern the motion of rockets in the vastness of space. Section 7. To the stars, rockets and Newton's genius. Rockets are incredible feats of engineering that use the basic laws of physics to achieve extraordinary things. By harnessing the power of thrust and understanding the interplay of forces, we can launch spacecraft beyond Earth's gravity and explore the cosmos. Newton's laws of motion are fundamental to rocket science. They explain why rockets move, how they accelerate, and how they navigate the vast distances of space. From the simple balloon rocket to the mighty Saturn V that carried humans to the moon, the principles remain the same: action, reaction, and the relentless pursuit of exploration.